So this is a pretty good lesson for like starting up a new year after a break. That's usually where this falls, which the book did, I think, by accident. But it's a nice review of a lot of things that we've done. So what's different about this lesson compared to anything we've done before is there's a fraction and a decimal mixed into the same problem. We've added fractions, added decimals, multiplied, divided, all that stuff. We've done that a good bit this year. But what they're doing is they're giving you one fraction and one decimal in each question. What they're going to do for you in the homework is they'll set up half the problems to tell you that in the end they want to end up with fraction answers. And they're going to tell you in the other half of the problems in the homework that they're going to want you to end up with decimal answers. So they'll start you with one of each. So this is a nice review of adding, subtracting, multiplying, dividing fractions, adding, subtracting, multiplying, dividing decimals, as well as turning fractions into decimals and decimals into fractions. So you get a lot of like small skills feeding into this homework opportunity. So if they want a fraction answer, the first thing you're going to have to do is turn all of the decimals into fractions. So if you want to be a little bit more of a participant in this video, what I would do is take some opportunities to pause the video, do the things that I'm saying we're going to do, and then unpause it and see if you did it right. But your first opportunity to do that would be to quick go through and just turn all of these decimals into fractions. If you remember how to do that, great. If you don't, we'll talk about that in a second. So if you don't remember how to turn a fraction into a decimal, you have two options. You could either put the number on top of its place, like this. You could go 6 over 10. This, you could go 75 over 100, but I'm not going to. This, we could go 5 over 10, but I'm not going to, I don't think, right now. But that's one thing you could do, is put the number over its place. Sometimes I might do that, sometimes I might not do that. Another thing you could do is just still continue to know these from the chart, or pull out a chart and look them up on the chart of the ones that we memorized. 0.75, I think we all eventually got to a point where we knew 0.75 was 3/4. So your quickest thing to do is going to be just use that from the chart. Putting 75 over 100 wouldn't be wrong, but when you go to multiply, you'd probably rather not have 75 or 100. You'd probably rather have the reduced form of that. Likewise, 0.5. We could put 5/10. It wouldn't be wrong to put 5/10, but I think it would be better to put the reduced form there of a half. Up here, you could have used 3/5. 3/5 would have been fine from the chart. I didn't do that time because I thought ahead a step, but we'll put that on hold for a minute, why I actually just did do the 6/10 there. But if you were here, I'd ask if you had a question about that, but you're not here, so I'll just forge ahead. So the next thing we have to think then is, do we remember how to add fractions? Or do we remember how to multiply fractions? Or do we remember how to divide fractions? And if you do remember how to do those things, pause the video, do it yourself, and then come back in and see if you did it right. If you're not sure how to do that, then just keep listening. So for this one, adding fractions, we need a common denominator. For this, the common denominator with 2 and 10, we'd use 10. This is already over 10, so I don't have to change that at all. This, if I'm going to change the bottom, I have to change the top. So if 2 turned into 10, I multiplied it by 5. So I'll multiply the top by 5. That was the thing that our book calls the name changer machine. Other books will say making equivalent fractions. But whatever you multiply the bottom by, you multiply the top by. And that's why I didn't use the 3/5, but I used the 6/10 a second ago. If I used 3/5, I'd have still had the common denominator made of 10, but I'd have had to change 3/5 back into 6/10. I'd be running in circles there for a minute. There's nothing wrong with that, but I sort of like thought ahead a step and just went straight from the get-go to the 10. Add these up now. 5 and 6 would make 11. Keeping the bottom at 10, when we add fractions, we need that common denominator. We don't ever change it. And now that this is improper, we'd have to fix it. 10 goes into 11 once. 1 left over when we divide. Keep the bottom the same, so 1 and 1/10 out of that. I didn't do a subtracting example. Subtracting is the same kind of thing. You need a common denominator. If you change the bottoms, you change the tops, that same kind of process. Multiplying, you have two choices. You could either multiply straight across. If you multiply straight across, 2 times 3 is 6. 3 times 4 is 12. Multiply across, get 6/12, just reduce it. I'm not going to do that because we also learned about canceling, which is a little quicker. Since this 3 matches this 3, tops can cancel with bottoms. We can just cross those out. 2 can cancel with 4. 2 goes into 4 twice, so I'll leave the 2 with the bigger of those numbers. I canceled everything from the top. I just need to leave a 1 there to fill that space. Remember when I was canceling, I could have left those 1s everywhere, but I just chose not to do that. And then the bottom, the only thing left is a 2. If we had gone across to get 6/12, you'd still be able to reduce to a half. All roads should lead to a half. Dividing fractions, you have to flip the second fraction. So if we flip this upside down, we have 3/8. Now we have 2/1, and now it's a multiply question. Same concept as a second ago. We could multiply straight across and get 6 on top of 8, but we'd have to reduce that. Or we could cancel. 2 can go into 8 4 times, so we could cancel 2 and 8, leaving the 4, the bigger number. The only thing left standing here is 3/4. If we did go straight across for 6/8, we'd have still reduced to 3/4. So half the homework will be like that, fraction work. Take your decimal, make a fraction, either put the number over the place, or just know it or look at it on your chart, and then remember the skills from before. Adding is common denominators, multiplying is straight across, dividing is flip the second fraction, and then multiply, divide, where all canceling can speed you up. The other half of the homework is the opposite kind of a thing. They don't want fractions, they want all decimals. So what we're going to have to do on these is take all of these fractions and make them decimals. If you remember how to do that, pause the video, do that real quick, check back in with me, but all fractions have to be made decimals before you go. To make a fraction into a decimal, the quickest thing you could do is use your chart. Okay, so 1/5, if you know it or remember it or can find your chart, 1/5 is 0.2. 2/5 is 0.4. 4/5 is 0.8. If you lost your chart, if you forgot your chart, if you don't remember any of the ones we memorized anymore, if they give you something that's not on your chart, you can always divide the bottom into the top. If you divide the bottom into the top, you could always make a decimal if you had to. So something like this, put the 5 out, put the 4 in. The 4 would need a decimal and a 0 to just get it going, but if you divide it, you'd get the point. We've tried to avoid dividing if we could. Then we have to remember our decimal skills. So if we're adding decimals, the key to that was, and here's again a point where if you remember how to add, multiply, and divide decimals, just do it. Pause the video, do it, check back in with me so you're getting the practice and not just spectating, because we know I can do this. The question is if you could do this. But if you don't remember, just keep listening. Adding decimals, we need to line up the decimal points. So if we stack these up with the decimal points in a line, the 2 lines up with the 7, we add it straight up, and we get a number. If this were something like a 0.25, make sure the 2 still lines up with the 7, and the 5 would live over there. And we'd get like a 5, and that's why. You keep the decimal places and the decimal points all lined up. But I'm going to erase that because that wasn't there. That's just a what if. Subtracting, same thing. Subtracting, you line them up, line up the decimals, go at it. Multiply, you multiply like the decimals never existed. Regular 4 times regular 7 is regular old 28. And then you look at the problem and count. You count all the digits on the right of decimal points. So the 4 counts because it's on the right. The 7 counts because it's on the right. So we've got a count of 2. To make this have a count of 2, to make these both count, we need a decimal right there. If I went back and took away this decimal point, then we'd only be counting to 1. If I wanted a count of 1, I would need to put this decimal point right in the middle before the 8 after the 2 to make only the 8 have a count of 1. If I had something else going on where I maybe go 0.07, now my count is 3. 4 would count. If I put a 0 there to change the problem, that would count. 7 would count. If I have a count of 3, I would need a 0 before the 2 to have 3 digits, and then the decimal at the beginning. Dividing, we want to go the first number always in the box. That's the dividend. We want the second number outside the box, that is the divisor. Dividing decimals, what you hope for is that this is a whole number. If it is, you just start dividing. But here it's not. So if this isn't a decimal, or excuse me, isn't a whole number, we move this decimal all the way to the right, so it creates a whole number. And then if you move the divisor, you have to move the dividend. We move this one spot, so I'm going to move that one spot. And the decimal is going to go straight up. 5 into 8 goes once, gets me 5. Feels like a remainder of 3, but we don't do remainders in decimal division. What we do is we throw on extra zeros to let us keep dividing. 5 into 30 goes evenly, that's 6 times, so that's our answer off of this would be 1.6. That's the main point of the lesson, but we have one more little topic that ties in slightly to this. But last little thing we're doing is this column of things. We'll do a group of letters that practices these. The variables are back. Okay, the variable is the name of, if you have a letter that's representing an unknown number. So you probably remember this from other days. Anytime we've had a variable, we've always done the opposite. If we had an adding problem with the variable, you would have to subtract. If you had a subtracting problem, you'd have to add. Multiply makes you divide, dividing makes you multiply. So on these, we hope you also remember when a number is next to a variable on the board, that means on my board they are multiplying. So all of these problems on the board have numbers next to variables. These are all multiply problems. You're going to have to divide to figure out what that number would be. So on this one, the divide goes pretty well. If we divide 5 into 30, 5 can go into 30 evenly. We'll just get 6 out of that. No big deal. We've done that before. If you feel like, hey, we did that before, we did that before. This one we haven't done before exactly like this. Here we'd have to take 5 into 21. The difference on this is 5 won't go into 21 evenly, so we've got to treat that a little differently than we did that one. 5 into 21 will go 4, getting us 20, but the remainder of 1 gives us a little bit of a problem. There's a couple ways you could handle this, but if the problem has all whole numbers to begin with, no decimals to be seen, I would just write a fraction out of this divisor, or out of this remainder. Take the 1, put it on the top. Take the 5 we were dividing by, put it on the bottom. If we get 4 1/5, I think that's the easiest thing we could do. You could have also thrown a decimal and thrown a 0 and kept dividing and gotten a decimal answer, but that's a little unpredictable. Sometimes when you divide with decimals, it ends right away, maybe 1 space more. Sometimes with decimals, when you divide, it might take you, remember the sevenths, when we divided with the sevenths, it took us 6 places before it repeated. And so you don't know what you're getting into there. You don't know how long it's going to take. I would recommend, if the problem has all whole numbers in it, just make a fraction out of the remainder. Put the remainder on top of the divisor, because you know right away you're going to be done. Whereas if you start adding zeros and going decimals, you don't know. It's not wrong. You want to do it, you do it. I just wouldn't recommend that. So this, if you got the hang of this, pause the video, do the next few, check back in with me. But for this, we've got 7 into 39. It's going to go 5 times, gets me 35. Remainder right now is 4. I'm not going to add zeros and divide till this ends. If you did pause the video and tried to go decimal with this, it's going to take you 6 places before it repeats. I would just go 4/7 with the remainder. Put this on top, put the divisor on the bottom, and you're out. This one, we'd go 0.07 into a 0.0049. It's always, if you're wondering, the number with the X is always the one that's wanting to do the multiplying. So when we go to divide, that's the number that has to do the dividing. That'll always be the divisor. That'll always go out of the box. 7 went out of the box, 5 went out of the box, 0.07 goes out of the box. Again, like we did a minute ago, you can't divide until this is a whole number. So we've got to scoot over 2, which makes us scoot this over 2. The decimal always goes straight up from where we scooted it. 7 into 4, 7's too big, can't go. So we need a 0 there when we can't go. 7 into 49 goes, it's 7. This will take a small step to the left just to create some space. If we're doing this one, we go 0.05 out, 1.3 in. Again, the number with the X always goes out. This has to be a whole number, so scoot it 2. So scoot that 2. When you make empties, as always, we need zeros to help. 5 into 13 is 2, gets us 10. Subtract gets us 3, drops a 0. 5 into 30 evenly is 6, that would just be 26. Last one is different. The last one's slightly different because I switched who's on what side. So if that makes you mad, you could just copy it down with 5x on the left, 27 on the right. There's no harm in just switching sides if that annoyed you. But you do have to notice that the number with the x is the 5, which makes the 5 go outside. Whether I write the 5 here or the 5 there, either way, 5's with x. It wanted to multiply. We'll make it divide. It's the divisor. 27 is in, so we'll go 5 times for 25, 2 left over. And I went decimals on the ones that had decimals. We can't do remainders on those. We just have to divide decimals till they end. But these are both whole numbers. I'm just going to do a fraction and cut it off by putting 2/3. And that's where we are. So homework is in 2 locations. There's a group of letters for this that I'll check on my paper. And then there's a set on these that's half fractions, half decimals. So this covered lessons 85 and 86 if you need any sort of notes from the book or advice from how they say to do this. Well, the homework we'll do off of this is a 202. 202, we're going to do A to F. The 202 A to F is like these problems with the variables. Then the main set in the back is set FF. Set FF in the back is half decimal, half fraction work the way we did over there. And they did it the way I did it. The first group is fractions up to 12. And then the next group is all decimal stuff up to 13. So they separated it like I did it in the same order that I did it. That's where we are, and you can check the next video tomorrow.